As usual, let's start by using link and then create a namespace of whatever week. Oh, it tells you them right there. That's neat. And they're arrays, so that's going to be easier. I don't know. Can I solve these tasks? Well, let's find out. 78. Okay, CS week 78. Quad this is week 78 of the Pearl Weekly Challenge. It's been a few weeks since I last did one of these. Let's see what's up. An array of integers, distinct integers. So we can do a little check there. Find leader elements. Greater than all the elements to its right. This should be pretty doable. Right. 9, 10, 7, 5, 6, 1. My instinct is to reach to a greater than selfie outer product, and you can kind of see how maybe the less one will get us more info, but how 10 is not. Oh, 10 is greater than all of the ones to its right. As is 6. What does this tell us about 7? We don't get quite the same pattern. Because 9 would indicate that, so this ain't the one. To its right. That's what I'm thinking I'm on the right track. Because this compares each element. To all other elements. So this is 9 compared to all the others. And it's greater than. So that's like, is 9 greater than 9? No. Greater than 10? No. Oh, since they're distinct, we don't care about greater than or equal. And if it's the first one, so and scan, that only indicates 10. Oh yeah, because they're all zeros. Get the flip side. Compared to... So what I'm thinking is some kind of scan of this outer product compared to the outer product itself should indicate whether they were all greater than elements to the right. But your starting element is... Your starting element is an edge case for this type of thing. It shouldn't be. Nine is not 1. 10 is 1. 7 is 1. 6 is not. You know what I'm saying? So we can do like and scan match rank 1. I'll get fucked. Right tack. And this indicates 10, 7, 6 and 1. Is this your boy? Sorry, I'm not verbalizing the thought process very well. I'm kind of just staring at matrices to see the pattern, but I think this is the guy. Can I reason my way out of it? Not entirely sure. Something like the outer product compares all numbers to all the other numbers. And this time we're giving it a less than relationship. So is 9 less than 9? Is 9 less than 10? Is 9 less than 7? Etc. Is 10 less than 9? Blah, blah, blah. And then the AND scan is basically all ones until the first 0. And what does this mean? Well, it's good for doing these types of left to right, right to left relationships, like all of the ones to the right, all of the ones to the left. So you see these a lot in your idioms for removing leading blanks, trailing blanks from text vectors. Christ. So if a number is greater than all the elements to its right, then all the elements to the right of that element will be zeros in the overall outer product. Is this right? Is this how it works? Yeah. And therefore the AND scan will have no effect on that row, and so they'll match each row. That's what the match rank one here is doing. It's comparing each row to each row and seeing if they're identical. Alright, you know what? Did it. So then it's just omega compressed by that, and there's your numbers. So leader element. The LMLNs. Omega distinct integers. Return elements which are greater than all elements to their right. Sure. And it's omega compressed by and scan match rank 1 outer product less than selfie omega. And that's it. Okie dokie. Well, I guess we can try it on the other one. Honestly, we can try it on any. Oh, the only one is 56. 46. Shouldn't put a massive one there. 6, 2, 4, 8. All the elements to its right. 9, 10. Oh, because they have to be going. Essentially, you need large ones on the left to make this work. Five is larger than all the ones to its right. What have I done wrong? Is it not? Oh. Huh? I'm sorry, what? What? Thought the logic was pretty good. Yeah, so that would give the right result in that case. But I'm mistaking the criteria here. This is not one that would return 10 is greater than all of its to its right. 3 is not, 1 is not, 5 is not, 2 is not, 6 is greater than 1. Alright, so maybe the test cases aren't that good. Let's just compare these guys. Whoa. How that work? Oh, sorry. And gets that. Okay. All the elements to its right. So 4, 2, 3, 1. In my mind, 10 is greater than all the ones to its right. Yeah. 3 is not, 1 is not. 5 is greater than all the ones to its right, and 3 is greater than all the ones to its right. Oops. Can't do that. Okay, well this is what I was getting before. So why did it work on this guy? Because 9, 10, because they were only descending, I think. So my logic was full of shit. Okay, 10 is fine because it's just outright the largest. Problem comes with 5. Is this guy here? Yeah, it's the second largest one. And they don't match. Could we do omega comma each? Will that not? Comma each. There we go. So now we can see which correspond to which. I'm thinking. I'm just being a bit thick right now, I think. We want 10, 5, and 3. Comma each. If it's all greater than elements to its right, maybe there's something about I want to say upper triangle. Because it's really, we're looking for just this type of pattern. So you start from a 1. Not a 1. Where's the number? The number itself will be on the leading diagonal. That'd be a 0. Also, we don't care about 1s to the left. You just want all zeros on the right, the top right triangle. So that's going to be the only criteria, I think. So one way is to just do the dot selfie iota omega. That's the upper right triangle, and those together. And we're looking for ones which are all zeros, I think. So 0 equals or slash. Okay. 10, 5, 3, and 1. This. Okay, now I've actually thought about it a bit. This makes more sense. We were on the right lines before, just needed to make the logic more sound. So, thank God I checked that. 9, 10, 7, 5, 6, 1. Still gets the 10, 7, 6, 1. And 3, 4, 5 will obviously be 5. That's the correct solution. Copy this. Place that there. Brilliant. Okay. If we want, later I can check for distinct elements, and that's just unique matches the original. So, for example, 9, 10, 7 is unique. 9, 10, 9, 10, 10 is not. Alright, but I'm going to move on now. An array. Can't really be asked to do that. But if I did another version of this with grade, I think I could do like a high rank major cells comparison, but I'm not going to do that today. An array containing positive numbers, B containing one or more indices from A. Rotate so that the number at the first index of B becomes the first element in the array. Array of positive numbers. Doesn't really matter what they are. Doesn't even say unique, so let's put 5 and another 4 in there, sure. Indices from A. 3, 5, 3 and 5. Left rotate. So I should put both 4s on the right hand side. So that the number of the first index of B becomes the first element in the array. In which array? In A? No, it's rotate, then left rotate A again. You know, I'll look at the examples. It'll clarify. So that the number at the second is the first element. We can go with their examples. 10 times 0 to 5 and 3, 4. Left rotate. To make it the 0th element. Oh lord, okay, well I'll make index origin the 0 just to fit with their thing. Okay. Essentially that's the... Oh. There's alpha. Really, it's to make 40. Left rotate. Oh, sorry, no, yeah, fourth element, element 3. So is that just a 3 rotate? Uh-huh. And then left rotate the fourth element to make it the 0th index number. And then output both. So that's just omega rotate rank 099 alpha. Yep, it's nice when it's basically built-ins. Example 2, again, this should just do it. 74263 rotated by 134. And we get 42637, 63742, 37426. There's not really much to be said about this other than it's the rotate primitive. And you want to apply it with a list of scalars. I'm going to rotate each of those scalars. Just make sure that the index origin is 0 to get the correct amount, otherwise you get an off by 1 error. So we call it left rotation. And really, apart from just local, set quad O to 0, it's a primitive thing, rotate. In fact, if you want to make it, there you go, now it's high rank. Rotate major cells in omega by scalars in alpha. No, that's a lie. Omega, alpha. Rotate major cells in alpha by scalars in omega. You know what? This is not long. Let's put it on a single line. Boop. I mean, that's literally what the APL says. Okay, so I will do the little end screen bit here. So pelvic challenge 78 and problems both begin with L, so that's leader element and left rotation. They're actually both fairly straightforward. I was just being a bit of a dum-dum at the beginning, just waking up. Don't think there's loads to say. I mean, when there are array-based challenges, then that's just APL's thing. Oh, I also need to correct this. Okay, so I've spotted a little artifact from my noodlings, which is get rid of that. We never actually use M. Okay, otherwise it's perfect. Okay. Yeah, so perhaps no, the fact that in leader element you have to find which are greater than all elements to their right means there's no way of avoiding this sort of n squared solution. You have to compare each element to all the elements. So an outer product is the easiest way to do that. And there are, I guess, efficient things going on down below. There's going to be vectorization of that somehow. And then the rotation was just kind of neat, because after struggling to pass the English, it turns out it's just the rotate primitive applied with rank. Okay, so this is the end of the APL bit. I thought... So I'm just going to say thanks very much again for watching. See you the next time I do this. And that'll be the end of the edited one. I'm thinking I should have a crack at learning a little bit of Raku now. Now, do I have Raku even installed on this machine? Let me get Raku. Raku Lang. Getting started. I might have rake. Rakudo Star. Rakudo. Rakudo. Yeah. Been a pretty nice few days, weather-wise. What have you been up to? Rakudo. No? Is that not how you launch it? Raku? What? Then what? I thought I just did that. Did it not do it? Alright. Rake. Next, the distribution. Should say always at the latest version. But why can I not? What's it called then? Raku? Rakudo? Fuck. Sudo? God damn it. I don't care, I'm not going to be using the latest features. Rakudo. I like fun ground. Playground? Jisho. Dojo. Rakudo. Paradise. Ah, good to know. Rakudo. 確かに、日本語が好き人が楽を作っていますか？楽を開発していますか？わかりませんけど、よく知りませんけど、そうと思います。日本語は下手ですね。そしてJavaScript. I don't wanna have to install from source. I thought I did it. So then what? It's a compiler. So you have to... So, I mean, at least we don't need this. We've done our code in there. I think I use Subble these days. Unlicensed. One day I'll buy. Oh, Sublime Text license. we have to make a pearl. No, okay, I don't know. I haven't done anything Raku so long. Let's limit this to maybe the next half an hour or so. Don't want to spend too long, annoyingly. So we have to start with use V6 of Pearl. Say hello. Am I allowed that? That's it, right? And then we're gonna call it Pearl Weekly. Here, Raku. You know what? It's just one folder. Who cares? Let's start with leader element.aplf. No, .raku. I wonder if Raku has a higher order. It's fairly functional, I get the impression. If there's a way you can write a higher order, you know, I can basically just reconstruct APL in Raku and then do all my... import that as some kind of library. Right. And then here, let's move you down a little. Weekly, week 78, damn it. No. Okay, and what Raku, lead element.raku. Raku dot. But it doesn't know what that is. But I installed something called Rakudo. And then to run it. The thing is, I swear I've done this on, I've done it on Windows. Just installed Rakudo. God damn it. Yes, language is good. How do I actually run a damn program? Tutorials. Just want to know why it didn't work. And I don't really want to install from source. You know? Bin. Raku. Is it just there if I extract here? Downloads Rakudo bin. Oh, Raku. No? ./Raku. Okay, so now I'm in like a terminal. I can say hello. Okay, and I can exit. Cool. ls Rakudo. That's Rakudo. So then I could do an alias at some point, but for now I could, for example, Rakudo / Rakudo / Rack. Hello, Rakudo / Rakudo. /Rakudo. Oh right, I'm in that directory. Okay. So then what? Rakudo /Pearl Weekly week 78 leader element.raku. Okay, and it just sort of compiles and runs it. Guess that's the way to do it. I'll set up an alias another time. So can you get arguments, or do we not care about command line arguments? We're just going to have some example ones. I know you can do that in the syntax. So my array is 9, 10, 7, 5, 6, 1. My rotations is, oh sorry, this is the leader element. Never mind, it's not the rotations. Ugh. Anyway, my array is that's fine. How do you write a function? Syntax, maybe? Oh Lord. La la la. Oh man. Functions. Yep. Yep. Subboy. Okay. So what's this? My sub leader element. Oh no. Sub leader element. And you can do curly braces to make anonymous, like defen. But we want arguments. An array with a default argument, which is this guy. I think you're allowed to do that. I don't know if you need to put my at the beginning. Oops. Alright, and then this is our sub. Let's do say array to start with. Let's see if that works. Nope. Maybe it is my sub exclaim phrase. Yeah. Oh, not actually calling it, so that's also a thing. Yeah. What about default arguments? Where is it? Welcome to the bit of the show where I just read documentation forever. Okay. It's not going to be very interesting for anyone else to watch. I think I'm going to kill it. Yep. Alright. Just get the one done. Come on. Come on. Slurpee. Comma separated list. Yeah. Am I just supposed to search everything? Raku default argument. And it's weird because I think I've done this before. It's just been so long, I don't know. Class, Raku, subroutines. Oh, This is just supposed to be in parens. Is that literally it? Could be. Lame. Oh yeah, and then it's not a my declaration. Okay. Hey, debugging the bugs. Awesome. Okay. Next. Let's take a look at my thing. We want to... So I guess we can sort of try and code this as a loop of some kind for element, the LMLN. Are you allowed to do that in array like this? Say LM. It's one of those that you're supposed to just try and okay, now I need to learn how for loops work. Iterating, doing math, core modules, grammar tutorial. So you don't want to do explicit for loops. Yeah. Okay, so don't like to use loop. We're not going to use loop. But there's going to be some way to... For set. Is that how you do it, huh? For at array to elements of array. Say element. Give that a crack. Doesn't do. Oh right, we don't actually ever call this. Leader element. Right. Okay. Then basically it's element greater than. Can you map? It's kind of dirty, but for. Can you do a drop or a take? Dot slash racket. My at a is is there a drop or a take? Sequences. Nope. What about, is there just one about arrays? Oh yeah, data structures, sets, bags, mixes. Enumeration. Callable. Fam, that's not what we want. Well, because I know I can like index A to 2, not 1, 2. You can't at A to 3. You can. Okay, so you can index arrays with arrays. That's neat enough. They're going to be unique, so I guess we could do index off, but that's a bit ugly because we know what the sequence is going to be. Like a dot length, is it? Nope. A dot len. Length is that keyword. Length a. Lord. Len at a. Length at a. Charles LMs at a. Sure. Again, not really supposed to do it this way. What about without? Drop the first one. Drop. Can you do 1 to 4? 1 to 4? Yeah, so you can do. This is dirt. Right. My index 0. For array I dot dot LMs. Well, I guess we can make that thing. It's in my length is LMs of my array. I to len. I to L. Blech. E. Oh, my sweet nested loops. Yeah. Oh, Lord. Say. E. Looks like that. So this seems promising-ish. Always starting from 19. Oh yeah, okay. And then I plus equals 1. You have to do that. Yeah. Don't know what the nil's about. So maybe it's L minus 1. Okay. Oops. And then say if that element is less than the other element. And this is our kind of outer product from before. Basically, it's if element so going element by element for each element. If it's greater than so yeah, at this point, can we not just do it? Is this what the mapping is? This is a mapping, like a functional style mapping, but in Raku. Almost there. Just do this one, and then I'm done. Element greater than E. then my result is empty. I think result. So can we do that? My a. Just do that. A dot append. Oops. A dot append 1. A dot. Thank God. Has some sensible things. Dot append my element. Ah, but as if that's greater than all of them. My a equals true true. A dot all and true is a dot all. A dot all true. I don't know. How do you check Raku if all elements? Yeah. Okay. Oh, they have a reduce. Oh my God. Yeah. Okay. So for a thing, my greater than is an array. What are comments hashes? Okay. Append my element is greater than a little element. Okay. Then we do if. Let's say reduce my G. Only one is not so yet. That doesn't matter. If at G dot first colon. What the hell is that? That's some kind of outer producty thing. Turns out it looks like I actually need to learn this language before I start trying to do things in it. Say okay. Ooh. So now we can do say okay if at a dot first colon this dot no. Sub true e x equals true, right? And then we do true say reduce true a. Is that how it works? No, not quite. There's a reduce somewhere. Who did it? Say reduce oh well, say okay if at a dot first colon whatever the hell this is dot true. Bool. What's a boolean? I have to care about types. Oh god. Right, I've give up at this point. $B. Sub true B. Return Lamine B? No, B? I don't know. True. True. Something true. What does that mean? Or what does that mean? Read. Smart map. Pred. Roll int numeric. Just want to know. What do I do? Just do true equals true. True equals false. Sub true B return true equals B. This is clearly awful. Say reduce true at A. Do array types now. So types all array null array oh sorry reduce reduce that result f say reduce say 123 dot reduce. No, we just want to know if they're all true. Say A dot reduce true $A infix. Yeah, okay. Let's look at that. Map. Combinations. Yeah, right. Okay. Different kind. I'm really on the arse end of being bothered now. So let's see, I've got enough pieces that I think I can do with my nasty little Thor mapping thing. True. G dot map true $A at A dot map true at A. That doesn't make any sense. True. Can't even do that. I've got a thing that works on booleans, and I have an array booleans. Well, I don't anymore, but I used to. Map. Yeah. Map. And do that. Raccoon map. Come on. Ooh. A dot map. Oops. Say map. A dot true. Not quite. Televised the sequence easily. Okay. What does this mean? It's like you're speaking Chinese to me right now. I think at some point, if I really want to do it this, I'm going to have to go through some kind of structured thing there. Join server B. I have one called true. Say A dot map true. Say at A dot map true $B. Sub true $B $B equals true, which is fucking terrible. Raku, all true, a boolean array. Enumble class array. Learn Raku in minutes. Come on. Subs. Turn. Do this, do that. Yeah. Don't care, just wanna know. Map. Truthy array. Yeah. Sub say map sub I. Say map true B. That's not yet. At array at A. Say map true at array at A. If I say map sub B return B equals true at A. Say map return true if true boom at A. Sorry. Boom. Yeah. Say map return true if dollar underscore is true at A. Say, and then reduce needs kind of a dyadic thing because it's between elements. GT just append true. Or as I guess. Bit ugly, but let's just do it. If the element is greater than the thing, then gt.append. It doesn't even matter what, because of the way we're doing this. Okay, and then after all that, we do if gt if elem's gt equals L minus I, then result dot append our element. I don't think that'll work. Okay. And at the end you want to return result. And let's not be saying stuff all the time. Are you allowed to just shove says in there? Say LMWT, say that. Are you allowed that? What? Oh, twat. That's another thing. I plus 1. I should. Oh, not quite. All the way around. Well, we know, for example, we want 10. Should be the second one. And that should basically say 5, 5, I think. It's the order of operations. Okay. You. There we go. Right, 4, 4, 3, 3, and the 1, 1, and the 0, 0 should do it. Say that is that. There are trues at 10, 7, 6, and 1. Why is it not returning the result? Oh, because we need to say. So, brilliant. I think this has done it then. 10, 7, 6, 1. Ah ha ha ha. Right, that was such pain. Oh, and let's 3 for 5. Whoa. Normal list. We're not just allowed to write plain old list in there. Yeah, okay. And the other one that was a weird edge case was like 9, 5, 4, 2, 10. Oh, you start with some of the largest ones, and then these were all descending. 6 is great, the largest ones. 2. So that's 10, 6. Let's do 4, 3, 6, 2, 1. 10, 6, 2, 1. Yep. That's it. Okay. I can actually submit one Raku. One Raku. Excellent. Alright. If you've watched all of this, you're insane, because this was boring as hell. Bye.